You ever just stand there in your living room and listen to your furnace do its thing? You hear all these clicks and whirs, and it starts, then it stops. I mean, it really feels like it has a mind of its own sometimes. Well, guess what? We're going to solve that mystery right now. Let's dive in and figure out what our heating systems are actually trying to tell us.
Right? Does its behavior ever just seem totally random? Like one day it's working just fine and the next it's blowing cold air, or it just quits for no reason at all? Look, you're not going crazy and you're not alone. Believe it or not, there's a very clear logic behind almost everything your furnace does.
I bet some of these look pretty familiar. That blast of cold air when you're just waiting for the heat to kick in, or the furnace that seems to try and then just gives up right after starting. Oh, and the constant on and off cycling that can drive you nuts. These aren't just random glitches, you guys. They are signals, and we're about to learn how to read them. Okay, so to understand these signals, we first need to meet the ones making the calls. It really all boils down to three key players that work together as a team to manage your comfort and, way more importantly, your safety. First up, the one we all know and love, the thermostat. You can think of this as the commander. It's pretty simple, right? It just senses the temperature in the room, compares it to what you've set, and basically says, hey, it's getting chilly in here, time to get to work. It gives the order, but, and this is key, it doesn't actually execute the plan itself. No, that job belongs to the control board. This thing is the furnace's brain. It takes that I want heat signal from the thermostat and turns it into a very precise step-by-step procedure. It's like the mission controller, making absolutely sure everything happens in the exact right order for a safe and effective launch. And finally, you've got the sensors. Think of these as the nervous system, or maybe the on-site safety crew. They are constantly reporting back to the brain, the control board, with critical updates. Hey, do we have a flame yet? Is it getting too hot in here? Is the exhaust venting properly? Their whole job is to protect the system and your home from any trouble. Okay, so check this out. This is how that whole team works together in a perfect, precise ballet. First, your thermostat calls for heat. Then, the control board starts the inducer motor to get a draft going. Next, a pressure sensor has to confirm that the draft is working. Only then does the igniter start to glow hot. After that, the gas valve opens. And finally, a flame sensor has just a few seconds to confirm, yep, we have ignition. If any single one of these steps fails, the entire process just stops. It is a safety checklist that it runs through every single time. So now that we know that sequence, let's circle back to those weird behaviors and see how they're not really mysteries at all. We are about to bust some of the most common furnace myths out there. Ah, this one. It's probably the most common complaint there is. You're all bundled up on the couch, the furnace finally kicks on, and you get hit with a blast of room temperature air. Your very first thought is, great, it's broken. But is it really? Okay, before you pick up the phone to call for a repair, just go check your thermostat's fan setting. See, if it's set to on, the blower is going to run constantly, 24/7, just circulating air even when the burners aren't firing. If you switch it to auto, the blower will only kick in when the furnace is actually making heat. It's so often just a simple setting, not a broken part. Man, this one is so frustrating. You hear it start up, you might even see the glow from the burners, you feel that tiny bit of warmth, and then silence. It's like it just gave up. And yeah, it feels like a major failure, but it's actually a safety feature working perfectly. Hey, remember that flame sensor from our ignition sequence? Well, its one and only job is to confirm to the control board that the gas has actually lit. If it can't see that flame within a few seconds, the control board makes a crucial safety decision. Shut off the gas immediately. It has to prevent raw gas from pouring into your home unburned. So why can't it see the flame? Well, over time, a thin layer of carbon buildup can form on that sensor, basically blinding it. The furnace is doing its job, it's making a flame, but the sensor can't detect it through all that grime. So it's not a failure, it's just a maintenance issue. The system is doing exactly the right thing by shutting down, because as far as it knows, ignition failed. We call this short cycling. The furnace runs for just a few minutes, turns off, then a few minutes later, it turns back on again, over and over. It never really seems to complete a full heating cycle. It's really easy to blame the thermostat, thinking it's confused, but it's usually just following orders. The real issue is another safety device stepping in. So meet the limit switch. This sensor's entire job is to prevent the very core of the furnace, the heat exchanger, from overheating. If that part gets too hot, the limit switch screams to the control board to shut off the burners right away. And the number one cause of overheating? You guessed it, a clogged, dirty air filter that's literally choking off the airflow. And this, right here, this really gets to the main idea of it all. Your furnace isn't failing, it's protecting itself from serious damage. That short cycling is a huge blinking signal that something, and it's almost always the filter, is blocking air from moving through the system like it should. The control system is doing its job perfectly. So the big question is, how do you tell the difference between a normal little quirk and a real warning sign? Let's break it down with a quick reference guide. Okay, on the left, you've got your normal behaviors. It is totally normal for the blower to run for a minute or so after the heat stops. That's just using up all the leftover heat. It's even normal for some furnaces to not start during crazy high winds because that pressure sensor can't confirm it's safe to vent. But on the right, these are the things to watch out for. If that cycling becomes more frequent, or if you ever have to manually reset a safety switch, that's your system telling you it needs attention. And listen, this is a point that I cannot stress enough. If a safety switch is tripping, it is tripping for a reason. Just resetting it over and over without finding and fixing the actual problem, whether it's airflow or venting or a flame issue, that's like disabling your smoke detector because you don't like the beeping. It completely defeats the entire purpose of having the safety system in the first place. So, as we wrap this all up, the big takeaway here is to stop thinking of your furnace as some mysterious, unpredictable box. Start thinking of it as a communicator, because once you understand what it's saying, you have the power to respond correctly. So let's just recap the big points. Most of these weird behaviors aren't failures at all. They are the control system simply responding to a command, a setting, or a safety concern. And you have to remember that safety will always win over comfort. Your furnace is designed to shut itself down rather than run in an unsafe condition. Every single thing it does is a logical signal about its own health and the environment it's running in. So the next time your furnace does something you don't expect, instead of just getting frustrated, maybe just pause for a second and ask, what is it trying to tell me? Because your heating system is always talking. The real question is, are you ready to listen?